Good morning. In the previous class, we have learnt about Arrhenius acid-base theory. In this class, we are going to discuss Bronsted-Lowery acid-base theory. According to Bronsted-Lowery, what is acid? According to Arrhenius, the substance which gives H plus ion in aqueous solution, acid. According to Bronsted-Lowery, acid is defined as the substance which can donate proton nothing but H plus, to other substances known as acid according to Bronsted-Lowery theory, or simply says proton donor is acid according to Bronsted-Lowery. Examples: HCl. In HCl, proton is there, H plus, so it can donate proton. So HCl is acid according to Bronsted-Lowery, and also HCl is acid according to Arrhenius theory. H2O acid according to Bronsted-Lowery theory. Base reverse, the substance which can donate proton, acid, right? Now the substance which can accept proton from the other substances known as base. What is base according to Bronsted-Lowery theory? The substance which can accept proton from the other substances is known as base. So simply says proton acceptor is base, right? Example: NaH3, H2O. These are the some examples of Bronsted-Lowery bases. Okay, so these are the definitions for acids and bases according to Bronsted-Lowery. So acid is defined as proton donor, base is defined as proton acceptor according to Bronsted-Lowery theory. Okay, let us discuss some examples. HCl plus H2O gives rise to H3O plus Cl minus. See this reaction. In this reaction, what happened? HCl donate one proton to water. So HCl converted to Cl minus, right? H2O accept one proton from HCl and converted to H3O plus, right? So here HCl is acid according to Bronsted-Lowery theory because it donate proton to water. So this is acid. Okay. Now H2O accept proton, right, from HCl. That's why this is base. This reaction is reversible reaction. You know what is reversible reaction? If the reaction takes place in both forward and backward directions, known as reversible reaction. Reactants, these are the products. Reactants to products, forward reaction. So this arrow indicates forward reaction. Again, products converted into reactants, back. This arrow indicates backward reaction. So this reaction takes place both forward and backward directions. That's why this is a reversible reaction. So in reverse reaction, what happens? Now here H3O plus to Cl minus, which can donate proton? Tell me. Yes, H3O plus donate proton to Cl minus. So H3O plus donate proton to Cl minus, so act as acid. Now Cl minus accept proton from H3O plus, so that's why this is base. So Cl minus again converted to HCl, H3O plus again converted to H2O. Okay, now here HCl and Cl minus are acid base pair, right? Bronsted-Lowery acid base pair. H2O and H3O plus acid base pair, right? So finally HCl in the forward reaction, HCl donate proton, that's why act as acid. H2O accept proton, that's why act as base. In the reverse reaction, H3O plus donate proton, act as acid. Cl minus accept proton, that's why act as base. One more example: NaH3 plus H2O gives rise to NH4 plus OH minus. See in this reaction what happened? Which one donate proton and which one accept proton? Yes, H2O donate proton to NH3. Okay, that's why H2O act as acid. It can donate proton to NH3 converted to OH minus, and NH3 accept proton from H2O. That's why this is base and it is converted to NH4 plus. Okay, in the reverse reaction, which one donate proton and which one accept proton? Yes, NH4 plus donate proton to OH minus. That's why NH4 plus act as acid and OH minus accept proton. That's why act from NH4 plus. That's why act as base. Okay, here NH3 and NH4 plus acid base pair, H2O and OH minus acid base pair. Okay, so finally if you observe, every acid converted into its conjugate base and every base converted into its conjugate acid. Conjugate acid H2O and H3O plus, H2O and OH minus, NH3 and NH4 plus. Let us discuss what is conjugate acid base pair. Conjugate acid base pair. What is conjugate acid base pair? An acid base pair which differ by one proton is known as conjugate acid base pair. Is known as conjugate acid base pair. Okay, what is conjugate acid base pair? An acid base pair which differ by one proton is known as conjugate acid base pair. In the first reaction, what are the conjugate acid base pairs? HCl and Cl minus, right? HCl and Cl minus, and also H2O and H3O plus, H2O and H3O plus. Okay, next one. In the second reaction, NH3 and NH4 plus, right? NH3 NH4 plus, H2O and OH minus, H2O and OH minus. Okay, so these are the conjugate acid base pair. Acid base differ by one proton. Okay, H2O and H3O plus differ by only one proton only difference. Okay, H2O 2 hydrogens, H3O plus 3 hydrogens. NH3 and NH4 plus differ by one proton. Okay, H2O and OH minus differ by one proton. So these are all conjugate acid base pair. So finally, in the Bronsted Lowery acid base reactions, every acid converted into its conjugate base and every base converted into its conjugate acid, right? So conjugate acid base pair means differ by one proton, acid base pair that differ by one proton. Okay, next one, important point. In conjugate acid base pair, if acid is strong, its conjugate base is weak. In the same way, if base is strong, its conjugate acid is weak. That means every strong acid has weak conjugate base and every strong base has weak conjugate acid. Let us discuss some examples. In conjugate acid base pair, if acid is strong, its conjugate base is weak. Okay, example, HCl, strong acid. What is its conjugate base? Cl minus, right? Weak base. HCl strong acid, its conjugate base, weak base. Next one, HClO4 perchloric acid, strong acid, its conjugate base ClO4 minus, weak base. ClO4 minus, weak base. Okay, so every strong acid has weak conjugate base. Similarly, if acid is weak, its conjugate base strong. Example, CH3COOH, weak acid. This is a weak acid. What is its conjugate base? CH3COO minus, right? CH3COO minus, strong base. Okay, CH3COOH is a weak acid and its conjugate base strong base, CH3COO minus. Okay, next one, H2O, water, weak acid, its conjugate base OH minus, right? Water conjugate base OH minus, strong base. Okay, in the same way for bases also reverse. Strong base, its conjugate acid weak, weak base, its conjugate acid strong. For example, Cn minus, strong base, its conjugate acid HCl, weak acid. Cn minus, strong base, its conjugate acid HCl, weak acid. Next one, C2H5O minus, this is a strong base, its conjugate acid C2H5OH, weak acid. Okay, next one, C2H5NH2, weak base, and its conjugate acid C2H5NH2 plus, C2H5NH2 plus, strong acid. If base is strong, then its conjugate acid weak. If base is weak and its conjugate acid is strong. Got it? So in conjugate acid base pair, if one is weak, another one is strong. Got it? Next one, let us discuss some examples. Acidic strength. Let us discuss some examples. Acidic strength order, HCOOH, formic acid greater than benzoic acid, COOH, benzoic acid greater than CH3COOH, acetic acid, CH3COOH greater than CH3OH, methyl alcohol greater than water greater than ethyl alcohol, C2H5OH, ethyl alcohol greater than NH3 greater than CH4, methane. So this is the order of acidic strength of some compounds. Formic acid, benzoic acid, acetic acid, methyl alcohol, water, ethyl alcohol, ammonia, methane, CH4, methane. Tell me what are their conjugate bases? HCOH conjugate base, HCOO minus, right? This one conjugate base, COO minus. Conjugate base. How a conjugate base is formed? By removal of proton. How a conjugate acid is formed? By addition of proton. How a conjugate base is formed? Removal of proton. How a conjugate acid is formed? Addition of what? Proton. Okay, removal of proton, conjugate base, removal of proton. CH3COO minus. Here what is conjugate base? CH3O minus. Conjugate base OH minus. Conjugate base C2H5O minus. Conjugate base NH2 minus. Conjugate base CH3 minus. So these are the conjugate bases. Now tell me, this is the strong acid, right? Among all, this is the strong acid. Which one weak acid? CH4 weak acid. That's why conjugate base order reverse. So this is weak base. So basic strength order. Which one strong base? This is strong base. Among all, CH3 minus is strong base. So basic strength order. So this is acidic strength order, no? Acidic strength. Basic strength is reverse. Strong acid, weak base. Weak acid, strong base. Got it? So this is the basic strength order. Basic strength order. If acid is strong, its conjugate base weak. If acid is weak, its conjugate base strong. Clear? So among all, CH3 minus is strongest base, HCO minus is weak base. Among all, HCOH is strong acid, formic acid, methane is weak acid. That's why weak acid, weak acid. This one strongest base. Here, comparatively other, this is strong acid, so weak base. Got it? So this is the order of acidic strength and basic strength of some compounds. Okay, in your material also given some order, you should learn that order, acidic strength. So acidic strength, top to bottom, acidic strength order decreases. Now conjugate base order, top to bottom, increases. Okay, let us discuss amphoteric substances. What is amphoteric substance? The substance which can act as both acid and base. That means that substance able to donate proton and also able to accept proton. So those substances are called as what? Amphoteric substances. The substance which can donate proton as well as accept proton. So it can act as both acid and base. Those substances are called as amphoteric substances. Okay, let us discuss some examples. Amphoteric substance, amphoteric substance, conjugate base. If it acts as acid, it has conjugate base, right? If it acts as base, it acts as conjugate acid also. Conjugate acid. Okay, amphoteric substance, conjugate base, conjugate acid. Example, H2O. Best example, H2O. H2 is an amphoteric substance because it is able to donate proton as well as able to accept proton. Okay, so how conjugate base is formed? By removal of proton. So remove proton, OH minus, right? OH minus. So if act as acid, so it can donate proton. So donate proton means converted into OH minus, and also accept proton, able to accept proton. If accept proton, that means act as base, right? Base means it has conjugate acid, right? So H3O plus. So water able to donate proton. If it donate, converted into OH minus. If it accept proton, converted into H3O plus. So what is the conjugate base of H2O? OH minus. What is the conjugate acid of H2O? H3O plus. How you can identify conjugate base? Removal of proton. Conjugate acid, addition of proton. H2O, remove proton, OH minus. That's why conjugate base. H2O, add proton, H3O plus. Right? Next one. NH3. NH3. Okay. Removal of proton, NH2 minus. Conjugate base, NH2 minus. Addition of proton. Addition of proton, NH4 plus. Removal of proton, minus H plus. Minus H plus. Addition of proton. Addition of proton, plus H plus. Okay. Next one. HSO4 minus. Minus H plus. SO4 2 minus, right? SO4 2 minus. Addition of proton. H2SO4. So HSO4 minus is a amphoteric substance. HSO4 minus is a amphoteric substance because it is able to accept proton and also able to donate proton. Okay, so it acts as both acid and base. Next one, OH minus minus H plus, O2 minus, right? Conjugate base. What is the conjugate base of OH minus? O2 minus. Why? Because remove proton, one proton remove, so O2 minus. Next one, addition proton, H plus, water, H2, OH minus plus H plus, water. So conjugate acid of OH minus is H2O, conjugate base of OH minus is O2 minus. Okay, these are the some examples of amphoteric substance. I think finally you got it. What is amphoteric substance? Which can able to donate proton as well as accept proton. Those substances are called as amphoteric substances. One more example, C2H5OH. C2H5OH. What is the conjugate base? Tell me. C2H5O minus, right? Conjugate base. Conjugate acid, addition of proton, C2H5OH2 plus, C2H5OH2 plus. Clear? So these are the some examples of amphoteric substances. Got it?